This is an introductory video, so let me first introduce the project. The DOTS traffic system is a powerful tool for creating massive city traffic based on the Unity DOTS Entities package. With this asset, you can build your own high-performance games for both PC and mobile devices. This comprehensive, all-in-one tutorial will guide you step by step through the entire setup process, from installation to a fully working environment. First, you need to install the necessary core packages. Upon importing the asset, the package installer window will appear automatically, but you can also open it at any time from the top menu. Click the Load Packages button to start downloading the required dependencies. If you want to learn more about these packages, you can always check the official documentation. Once the download is complete, the main .city scripting define symbols will be added to your project automatically. Now, it's time to add the initial components to your scene. Go to the top menu, select the Spirit 604 tab, open the City Editor, navigate to Create, and click City Base. In the window that appears, you can select either Hub or Hub Base. In most cases, you should choose Hub Base, which is a pure traffic solution without any additional features. The standard Hub option is used mainly for demo purposes. Next, select your world simulation type, DOTS or Mono. DOTS runs the traffic and pedestrian simulation entirely in the DOTS space. In contrast, Hybrid Mono runs the physics simulation on Mono behavior scripts while taking input from the DOTS entity simulation. Then, depending on your specific use case, select the entity type for both traffic and pedestrians. Press the Create button. After that, drag and drop the test camera into the scene. Make sure your camera contains a cull point object. Note that a cull point is generated automatically during HUG creation. If a camera is already present in the scene, the cull point will be automatically created as its child object. In our case, we can delete the extra cull point from the scene because our test camera already has one. Finally, select the hub base object in the hierarchy and click Generate in the inspector to create a new subscene. And that's all you need to get started with the initial setup. Now, let's move on to the next steps, where we will configure the traffic nodes, set up the roads, and bring our city simulation to life. In this section, we will add cars from scratch. First of all, we should adjust the vehicle prefabs to ensure they drive correctly on the ground surface. Select your road in the scene. This can be a flat surface collider or, in our case, the road mesh itself. As you can see, the road is assigned to the ground layer. Open the Hybrid Traffic Car Monoskin Base Arcade prefab for mono behavior vehicles, and ensure that the raycast layer matches the ground layer. Do the same for the DOTS prefab if you plan to use DOTS cars. Open the Entity Custom Physics Base prefab and verify that the cast layer is set to ground. There is no name displayed, but the layer index must match the index of the ground layer, which is 18 in our case. Next, we need to open the Car Prefab Creator window to generate our vehicle prefabs. Drag and drop your desired vehicle prefabs into the window, and then click the Scan button. Next, open the Save Settings tab. Here, we need to configure our preset parameters. Set the entity type. In our case, let's select Hybrid Mono Physics, which will work perfectly with our mono behavior world setup. Keep in mind that for mono behavior cars, you should select the Hybrid Mono simulation type in the general settings. Conversely, for DOTS cars, you need to select the DOTS World Simulation type. Also, note that when working with DOTS cars, you must specify which exact DOTS car you want to use inside the traffic settings. Additionally, before generating the subscene for DOTS vehicles, you will need to enable the Copy Physics Shape option inside the hub object, selecting your designated ground layer. This ensures the ground collider is cloned into the subscene, giving the DOTS cars a physical surface to drive on. As you can see, the subscene was successfully generated and the physical colliders were cloned. Since we are creating a mono behavior car, let's switch back to the mono simulation type. Let's go back to the Car Prefab Creator. After that, specify your save path and press the Create button again to finalize the preset. Now, let's experiment with the prefab we just created. Check the Allow Override box so we can modify the prefab during creation. Drag and drop the newly created prefab into the scene. Next, open the Additional Settings tab. Let's enter a new wheel offset value and click the arrow button to apply the setting. Now press Create again. As you can see, the wheels has moved along the y-axis. Let's also experiment with the local offset and recreate the cars. Using this workflow, you can quickly override settings and experiment with different parameters on the fly. In the Prefab tab, you can specify parameters specific to the desired vehicle. Moving on to the Graphics tab, you can select the Wheel Sharing option. This allows all wheels to share the same model, significantly reducing memory overhead and draw call usage. Now, let's locate our created preset. Find the traffic Baker reference in the scene to check our results. Next, locate it inside the subscene as well, and make sure that both presets match. You can manually synchronize these presets in the inspector using the Sync to Subscene button, or you can just apply a prefab for the edits. Alternatively, you can instantly sync all presets and configs at once via the main hub. With that, we have successfully created our first mono vehicle. Let's launch the scene and see it in action. In this section, we have learned how to create both mono and dots vehicles from scratch. Now that our core vehicle prefabs are ready, let's move right into the next step, where I will show you how to customize and fine-tune the advanced physics settings for your dots cars. This scene is specifically designed for customizing custom physics cars. First, select the vehicle custom spawner and choose your spawn type, either player or traffic. Next, open the subscene and select the vehicle collection to view your vehicle presets. To speed things up, you can also directly drag and drop any car you want into the subscene without using presets at all. Let's open the player vehicle prefab. First, set the origin move type according to your needs. Then, adjust the initial position of the suspension and the alignment of the wheels by dragging the green arrow in the scene view. Don't forget to set the correct wheel radius and width. Finally, configure the cast type and cast layer. As always, you can read more about these specific parameters in the official documentation. Now, let's launch the scene and see it in action. You can press the tab or arrow keys to instantly change your test location. Let's open the vehicle prefab during runtime to experiment with different parameters. Remember to save your prefab after making changes, and then press the backspace key to reset. Let's pass an obstacle. You can hold the left mouse button and move the cursor to change your camera view. Now, let's change the suspension length and pass the obstacle again. Next, let's tweak the mass and stiffness. As you can see, the car starts to jump. Parameters like stiffness, damping, vehicle mass, and the apply impulse offset can all drastically affect this behavior. The apply impulse offset calculates forces from the contact point of the wheel. It's crucial to ensure that this offset and the vehicle's center of gravity are close to each other. If the center of gravity is too low, the car will almost never flip over, but the body and suspension will feel less stable. If it's perfectly in the center of the car, it will behave much more like a real vehicle. Let's reset the parameters and set the apply impulse offset back to 0. Taking a little drive now, the car starts to roll on its side. That's because the center of gravity is low, while the apply impulse is set too high. Moving on, let's look at the custom steering limit parameter, which sets the steering angle relative to your current speed. Currently, with it disabled, the car turns instantly at any speed. To fix this, enable custom steering limit and set the limits according to your speed in meters per second. Now, let's head over to the ramp and press space. The transient force parameter is responsible for holding the vehicle steady on an incline. Watch what happens when we disable forward transient force. The car instantly starts to roll down the ramp. The same applies to lateral movement, so ensuring you have enough lateral friction and lateral transient force is key. Press the tab key again to change locations and take a final test run to see how the car handles. You can also press the F1 key or click the car icon to instantly switch to another vehicle. Any DOTS vehicle in your project can be customized using this exact same workflow. Now that our vehicles and custom physics are perfectly dialed in, let's move right into the next section of our guide. In this video, we will be adding legacy pedestrians. Legacy pedestrians are a hybrid pedestrian entity that combines a standard Unity animator with an ECS entity. The list of animations currently supported by the animator can be found in the official documentation. Let's drag and drop the following pedestrian models into the scene. If you want to use project animations, the rig type must be set to humanoid. Select the pedestrian skin factory. Drag and drop your pedestrians into the factory. Enter your desired save path. Set custom names for your pedestrians. Click Create. For the newly created pedestrians, make sure to assign an animator controller. Now let's create ragdolls for them. In the current version of the project, the ragdoll consists of default Unity colliders, so the surface must have a default collider. Drag and drop the model into the scene. Add the pedestrian ragdoll component. Create a ragdoll on the root object. Drag and drop the corresponding bones into the ragdoll wizard. Check the colliders on the bones to ensure they fit correctly and are of the proper size. Create a prefab from the model. Now, open the ragdoll cloner. In the ragdoll cloner, set the source character to the very first ragdoll you created. Place the remaining models into the scene. Create prefabs for them and add the ragdoll component as well. Set the target characters to the rest of the newly created ragdoll prefabs. Make sure that the rig of all models is a perfect match. Press clone. The ragdoll models have been successfully cloned. Double check them to ensure they are identical. Assign the resulting ragdoll models in accordance with the created pedestrians. Congratulations! You have successfully added legacy pedestrians. In the next lesson, I will show you how to integrate GPU pedestrians. In this video, we will be adding GPU pedestrians. A GPU pedestrian is a pure ECS entity whose animations are calculated and rendered directly on the GPU. Open the Animation Baker tool. Drag and drop your pedestrian models into the scene. Drag and drop the skinned mesh renders into the Animation Baker window. Make sure that all models have an animator component attached to the parent object. Drag and drop your animation clips, or in our case, let's select a pre-made template. Press the Create New button. Let's experiment. Press the Preview button and select different characters to review their animations. As you can see, each clip has a frame rate of 30, and right now the textures are too large, so let's optimize them. Tick the Allow Interpolation option. Adjust the frame rate for each clip to ensure there are no visual deformations. Remember to press the Update Texture button after each frame rate change to apply the updates. Now the texture is half the size it was before. Set your desired save paths. Press Save as New. As you can see, we have binding errors in the console because the animations are not bound yet. Let's bind them from the drop-down list according to the animation collection list. Let's save the prefabs again. The prefabs have been successfully saved. Let's drag and drop one of the prefabs and launch the animation just for testing purposes. Now, we are ready to pass the resulting prefabs to the factory. Open the Crowd Skin factory. Press the plus button. Drag and drop the generated prefabs into the slot. Next, let's find the ragdolls created in the Legacy Pedestrians tutorial. Assign the resulting ragdoll models in accordance with the created pedestrians. The GPU pedestrians have been successfully added. In this section, we'll create a simple road network. First, we need to set up the initial components. Select the desired world simulation and entity types. Generate a subscene using the hub object. Press Move Back to return the road route to the main scene. Now, we can build a simple intersection. In the Unity toolbar at the top, navigate to 604 Spirit, City Editor, Create, and select Road Segment. Enable the Position Handle option along with snapping, since our map is based on a grid. Set the lane width and the intersection width. Each segment has its own custom settings. In this case, we can configure 3 or 4 sides. Configure the pedestrian settings, pedestrian crossing offsets, and corner connection types. Next, duplicate the segment we just created. Copy the segments by pressing Ctrl-D and place them according to the road. Open Path Settings. We can change the speed limit and relocate the waypoints. Drag the position handle to adjust the path's trajectory. In the Custom Settings, select 3 sides. Press the caps lock key to rotate the segment. Now, let's create a turning segment. Adjust the crossroad width according to the road. After placing all the segments based on the grid, we need to connect them. Open the road parent object. Press Force Connect. To connect crosswalks between them, simply tick the Connect Crosswalk option and press Force Connect again. Once the path is generated, click Bake Path Data to verify that the structure is built correctly and to bake the data. Open the hub object and regenerate the scene. We have successfully created a simple scene. In the next section, I'll show you how to build an advanced road network. In this section, we'll focus on creating an advanced road network. We will start building the scene by creating a custom straight road, which is designed to form straight roads of any shape. Place it roughly where it should be located. Align the nodes so that they run along our road layout. Set the lane width and the divider width so that the tracks align perfectly. Now that the nodes are positioned correctly, start extending the road by holding down the left Shift key and clicking the left mouse button. As you can see, we have accidentally selected the ground. Let's lock it. Let's continue extending the road by holding down left Shift key and clicking the left mouse button. After placing all the path nodes, begin aligning them by location and rotation to perfectly match the road geometry. Once you have finished the segment, you can set a speed limit for it in the path settings. Create all the straight paths at this intersection in the exact same way. With all the straight paths ready, we need to construct an intersection. Create a custom segment. In the advanced settings, select Intersection Creation. Select the nodes of all direct paths present in the scene. Press the Create button. That was the first method for creating an intersection. Now, I'll show you the second way to build them. Create another custom segment. Set the lane width and divider width to match the existing road in the scene. Arrange the nodes on the scene according to the layout of the roads. Enable customized nodes and create the third missing node. The nodes must be positioned so that the white arrows point away from the center of the intersection. Click the Open Traffic Node Editor button. Here you can customize each node individually, then click Set Settings. After placing the nodes, select Auto Crossroad in the additional settings. Press the Create button. Now let's add some additional paths. Open the Path Creator tool. Select the nodes between which you want to create a path. Choose the lane indices for which you want to generate a path. When the green path preview appears, it means it's ready to be created. Press the Create button. After finishing the scene layout, click Bake Data in the road parent. The console will show warnings indicating that some traffic nodes have empty left lanes. Let's locate them. Open the Traffic Object Finder tool. Find the problematic nodes using their unique instance IDs. Fix them according to the instructions in the console message. In this specific case, there's nothing to do. You just need to complete the road network so there are no dead ends. Once you have finished creating the scene, click Generate Subscene in the hub object. Now, click Move Back on the hub object to continue working on the road. Let's convert a regular segment into a custom one that will be positioned on the bridge. Disable the lights in the Lights tab, as we are going to use the Scene Traffic light instead. Adjust the crossroad width to perfectly fit the intersection. Create a merge crossroad leading to a one-way road. Press Flip Sub-Lane Node. Set 2 lanes for the one-way side. Switch the one-way direction. Adjust the crossroad width and sublane distance to fit that specific intersection. In the other settings, press Convert to Custom. From this point on, this segment becomes a custom one. In the Snap settings, press the Snap to Surface button to align all objects of the segment to the bridge surface. Now, let's build an access ramp to the bridge. create a custom straight road. Move one of the nodes to merge it with the existing intersection. Place another node at the entrance of the ramp. Set the lane count to 2 and tick the one-way option. In the path settings, tick the path handles and buttons option. We can now add an inner waypoint along the ramp by pressing the plus button directly in the scene view. Move the newly created waypoint according to the curvature of the ramp. After that, in the snap settings, snap the road along the ramp surface. Readjust the waypoint position if necessary, and snap it again. Now, you have learned the common principles of how to create most road types. Let's move on to creating a traffic light. Let's open the traffic light prefab in the scene. Add the traffic light object and traffic light object authoring components. Now, let's start creating the light frames. Let's create an empty game object and add a traffic light frame component to it. Let's create a traffic light object specifically for a pedestrian traffic light. Now, let's assign the traffic light signals to the traffic light frame. We'll assign an index direction to the pedestrian frame so that the raycast originates from it correctly. Now, let's open the traffic light's parent object and click Assign Initial Child. Let's remove the pedestrian traffic light from this list because it has its own dedicated traffic light object. By default, the traffic light index is automatically assigned to -1, so let's change it to 0. Let's do the exact same for the pedestrian traffic light. Let's open the traffic light's global settings. As you can see, we're getting a Crossroads Not Found message because the roads are currently closed inside the subscene. Open the hub object and click Move Back. Let's open the traffic light's global settings again. Unfold the Auto Light Connector tab. Click Reconnect Lights to automatically connect all the lights in the scene based on their positions. As you can see, the number of reconnected lights is 0 because they were already connected. Untick the Connect Only Missing option and try again. This way, we automatically connected all the traffic lights on scene. There's one more thing. If you're using dot simulation and want to use traffic lights in the main scene, you need to enable the Is Active option in the traffic light hybrid service. For mono simulation, this service is enabled by default. In this section, we will do a complete overview of how to set up traffic lights and configure their timings. The Global Light Settings window allows you to connect any object to a traffic light or modify the traffic light timings for any segment. Now, we can connect the created traffic lights. Select the desired light handler. By default, each segment contains 2 handlers. Then, select the target traffic light. And that's it. The traffic lights are now connected. This method allows you to connect traffic lights, traffic nodes, and pedestrian nodes. Let's observe the scene layout. This tool displays the traffic light settings for each individual segment. You can also see which traffic lights have been turned off. In this menu, you can replace the global light settings for specific segments. Press the asterisk button, select the new settings, and click Replace. We can also select other light connection types: traffic node, pedestrian node. This allows you to change the connection between traffic lights and scene objects. Let's return to the previously created segment. Select the traffic light crossroad component to modify the traffic light timings. By default, the timings are managed by a shared configuration file. To set custom timings, enable the Custom Settings option. Add the desired states using the plus button. Customize the timings according to your preferences. Add and configure the remaining states. Next, we can loop the timings for another light handler. Press the Loop Time Settings button. Select the Source Data Handler Index, which equals 0 in our case. After that, select the destination traffic light by pressing this button. Click the Loop Time button. Now, the second traffic light handler with index 1 has a looped timing synced to the first handler. We can also create a custom traffic light handler for a specific path. Enable the Custom Arrow Settings option. Select the desired traffic node. Select the target path. The selected path is now highlighted here. Press the Add Custom Light button. The arrow light handler will now appear in the list of handlers. Here, select the related traffic light handler and adjust the light duration. To remove the newly added arrow light handler, simply press the Remove Selected Path button. Now, we can learn how to manually assign the lights to the road objects. In this video, we will create simple parking spaces. Create a custom road segment. Press the Caps Lock key to rotate the segment. Place the nodes on the road correctly. As you can see, the nodes are slightly misplaced. Let's fix it. Enable the Add Half Offset option. The nodes are now positioned correctly. Turn on the Parking Builder mode. As you can see, there is a new object in the scene, which marks where the parking line will begin. Enable the Position handle. Place it where the first parking space will be located. Select the number of parking spaces. Set the parking slot size. Enable snapping. In our case, the tile size is 1.9, so let's set it to half of that value. Now, adjust the parking position. Enable the rotation handle. Change the rotation of the parking spaces by dragging the circle. Set the line handle object type to parking line. Change the rotation of the parking line by dragging the circle. Now we are ready to create the entrance path. Select the Path tab. Click the Show Select Path buttons. Select the source path. Enter the speed limit. Click Create. Create additional waypoints for the path by pressing the plus button in the scene view. The node clone count determines the number of nodes that will be copied for offset paths from the first entry path. In our case, only one waypoint is copied, while the others will be placed with an offset. If necessary, open the path settings for more fine-tuning. Let's do the same for the exit path. Select the Exit tab. Press the Create button. Insert the waypoints. If required, you can also customize the waypoints of the desired route. Open the Path tab, select the Offsets tab, and then choose your desired path. Drag the waypoints for the selected path. After all settings are complete, press the Create Line button. As you can notice, we forgot to configure the pedestrian nodes. Let's fix it. Click the Edit button next to the line you have created. Open the Pedestrian tab. Configure the type of pedestrian node and its weight. Then, set the offset for both the entrance and exit pedestrian nodes. The green node is a default pedestrian node. The blue node represents the entrance node to the parking slot for pedestrians. Press the Create Line button, and that's it. The parking line is created. Now, let's set up the traffic group for the parking lot. Press Edit Line. Open the Path tab. Adjust the traffic group settings. Traffic groups determine which vehicles can enter and spawn on these specific paths. Recreate the line. Open the Path View debugger to see the final result. Select the traffic group type in the debugger. As you can see, our car parks now have a different traffic group assigned. In the next lesson, I will show you how to create a traffic area for advanced parking. In this section, we will create a traffic area for advanced parking. The traffic area component is designed to manage vehicle queues in confined spaces to avoid congestion. For example, it can be used for car parks or gas station queues. To get started, create a custom road segment. Enable the custom settings. Configure the current traffic nodes. Position the entrance and exit points for the parking lot. Turn on the Parking Builder mode. Now, we can create the first parking line. The process of creating a parking line was explained in detail in the previous video. Choose the traffic node connection source type, which ensures that the exit paths correctly connect to the traffic node. Select both the source traffic node and the target traffic node. Create an entry path and set up its waypoints. Next, create an exit path and configure its waypoints. The Node Skip Last Count parameter defines the number of final waypoints in the offset paths that will be excluded from creation. We also need to configure a backward motion path for the vehicles. Open the path settings. Select the waypoints that require backward motion. In our case, these are the first two waypoints. Using the same method, let's quickly create the remaining parking lines. Create the entrance and exit traffic nodes for the segment. Generate the internal paths of the segment. Create a new game object and attach the traffic area component to it. The traffic area component features two key parameters, max queue amount and max skip enter order amount. Max queue amount specifies how many cars are allowed in the queue. If the queue is full, the entrance to the traffic area closes, so choose this value based on available space. Max skip enter order amount determines how frequently exiting cars yield to incoming vehicles. In our case, setting this parameter to 1 means an exiting car will only skip one incoming car. Enable the Show Scene node option. You can change the button type if needed. You can also filter the types of traffic area nodes displayed. The default node type performs no specific action, but formally belongs to the traffic area. The Enter node is the node that closes automatically when the queue reaches its limit. The Queue node defines the exact location where vehicles will wait. The Exit node is the point where vehicles leave the traffic area. Select the Queue node type, then click the corresponding node directly in the scene. Follow the exact same steps to add an Exit node. The remaining nodes can be left as default nodes. You can customize the node colors if you prefer. For convenience, let's move the traffic area object to the center of the parking lot. We need to add an Enter node, so let's set that up now. In the custom settings, delete the old path. Add a new traffic node and place it in the required position. Create the paths to connect it properly. Now, we are ready to add the Enter node to the traffic area component. The only thing left to do is to connect the pedestrian nodes of the parking spaces with the city's pedestrian network. Disable the traffic light for this segment. That's all. Let's launch the simulation and review the final result. In this video, we will create a route for public transport. Let's start by setting up public vehicles. Open the tram vehicle prefab. For public transport to function, each vehicle must have two components: traffic public entity authoring and car capacity component. Create an entrance game object and assign it to the car capacity component. The entrance game object must have a traffic vehicle entry authoring component attached. Enable the predefined route option, which ensures this vehicle will only spawn on the specifically created, defined road. Set up the desired idle time. Specify the number of exiting pedestrians at a bus stop. Set the time duration between pedestrian entrances. Let's look at how to add multiple wagons to our transport. Duplicate the currently created wagon several times. Then, add the traffic parent wagon authoring component to the parent object, and assign the duplicated wagons to it. Now, let's create a mono version of the tram. The mono tram consists of two main parts, the entity and the hull. The entity is set up exactly the same as before, with the only difference being the absence of a visual mesh. The hull contains all the mono behavior physics parts. Create the mono vehicles using the exact same workflow shown in the vehicle creation tutorial. Remove the arcade vehicle controller component and remove its reference from the script switcher. Duplicate the currently created wagon several times. Add the train wagon runtime authoring and train wagon mono adapter components to each of them. Finally, add the train runtime authoring component to the parent object and assign the newly created wagons to it. Now we are ready to create a route for the tram. Create a new game object and add a traffic public route component. Select the tram traffic public type. Choose the tram car model. Let's start selecting the paths for our route one by one. After that, we need to change the traffic group for each selected path. Open the Path Data Viewer. Set the Path Viewer type to Traffic Path Group. Now, let's start changing the traffic type of each path. Enable multi-selection to select multiple paths at the same time. Once all the paths have been selected, set the traffic group mask to Forbidden and select all groups so that no default cars can spawn here. Set a custom color for the tram paths. As you can see, we have successfully changed the traffic type of all the paths. Now, we have to change the pedestrian node type to traffic public stop stations and connect them to the traffic nodes. You can connect the pedestrian node and the traffic node by pressing the Tab key while selecting the traffic node. Change the traffic node type to traffic public stop. If you want to limit the number of pedestrians waiting for public transport, simply change the capacity parameter. That's it. The tramway is completely set up. This section will provide a complete overview of the pedestrian nodes. A pedestrian node is used to create walking routes for characters. Let's create a pedestrian node from the context menu. A pedestrian node can be connected to a traffic node, and when connected, its color changes to blue. You can connect them by placing the mouse cursor over the traffic node and pressing the Tab hotkey. Connecting with a traffic node is necessary when pedestrians need to enter or exit vehicles. You can also quickly connect a pedestrian node to other nodes using the Tab button. The related traffic light handler property refers to the traffic light that is directly connected to this node. Let's try to connect some nodes. Let's move on to the types of nodes. Sit nodes are used to define areas with benches. House nodes are used for entering buildings. The idle node type is used to make a pedestrian idle for a certain amount of time. The car parking node is used for entering vehicles in a parking space. Talk area nodes are used to create pedestrian congestion areas where characters communicate with each other. The traffic public stop station node is used for pedestrians waiting for public transport. The traffic public entry node is used for entering public transport vehicles. The Can Spawn in Vision option allows pedestrians to spawn within the player's camera view, which is useful for spawning inside buildings. The node capacity parameter is used for parkings and benches, where a value of -1 means infinite capacity. Priority weight determines the weight or probability when a pedestrian selects one of the available routes. Custom achieve distance is the custom distance required to reach a node, and if it is set to 0, the standard value is used instead. Chance to spawn determines the exact probability of a pedestrian spawning at this node. Max path width defines the width of the path between the connected nodes. Custom max path width is used when you want to explicitly enforce a custom path width. The Has Random Offset option randomizes the exact offset point when this node is selected as a target. Now, let's create a talk area and select the appropriate talk area type. As you can see, there are various customization settings available for this area. Let's see how a bench is set up. To set up a bench, you need to select the Sit type and add an additional component called Pedestrian Node Seat Settings. Here, you can adjust the exact position of the seats and define the point where the pedestrian sitting animation begins. Let's go back to the scene view. We will now take a look at the Advanced Connection Settings. Open the Advanced Connection Settings window. With these tools, we can split an existing link, connect to the current link, create a custom width for a link, or modify the current width. Let's look at each of them. Select the Join to Connection option. Select the first and second nodes using the Tab hotkey. We are now ready to connect to the line. Click Join Connection. If you want to connect specifically to a line position, enable the Attach to Line parameter. You can undo any changes if you make a mistake. You can also split an existing connection. Select the target node. Enter the desired number of split nodes. Press the Split Connection button. You can also modify the current connection width. Now, let's try to change the current width of the connection. Enter your desired value for the width. We can also create a custom width targeted at a specific node. That's all for now, and in the next section, I will explain in detail how to use the Pedestrian Node Creator. This section explains how to use the Pedestrian Node Creator. The Pedestrian Node Creator is a specialized toolkit for creating and connecting pedestrian nodes efficiently. Let's start by creating a Pedestrian Node Creator object. To place a temporary pedestrian node, press the Tab hotkey, and after choosing the position, press the E hotkey to create it. To select a pedestrian node, press the W hotkey, and then press the E hotkey to connect the nodes together. You can also easily split an existing connection. There are two modes available for splitting connections, using a strict right angle or using a custom angle. For this example, we will choose a custom angle. Setting a custom angle of 5 degrees means that the ray cast for the split connection around the node will be cast every 5 degrees. As you can see, the connection has been successfully split. You can also connect a whole sequence of nodes at once. Tick the Auto Rejoin Line option. Let's connect several nodes at once. Press the W hotkey on the starting node, and then press E on the end node of the line. Let's select a few nodes. You can move several nodes at the same time. Press the W hotkey on each node to include it. Set the multi-handle type to All. You can also enable handles for all nodes simultaneously. Turn on Show Border Routes to visualize the exact boundaries of the walking paths. Let's try to change the maximum path width of the routes, and as you can see, the width updates for all of them at once. Turn on Show Selected Node Settings to view the properties of the currently selected node. Click Show Traffic Node Connection to display lines connecting them to the traffic nodes. Enable Allow Connect Traffic Node, and now you can link pedestrian nodes to traffic nodes using the Tab hotkey. To see the unique parameters of the pedestrian nodes directly in the scene view, select the Show Unique Info option. As you can see, the parking area has unique nodes that differ from the standard prefab ones. In the Selected Node Settings tab, we can easily modify the properties of the currently selected node. That's all you need to know about pedestrian nodes.